Hello, Dr. G here, and this video is how do I clean data? So I actually heard from a student asking how to clean her data for a project that I had assigned. And I thought, this is a really good question. I actually often spend more time cleaning up my data than doing the actual analysis. That has happened to me on several projects. So what does it mean to clean data? Like, I know what I'm saying when I'm telling her to clean the data, but for her as a new person, like, what does that mean? So you're cleaning your data when you take a data set that you cannot do analysis on, and you put it in a form that basically you can do the analysis. And this happens for several reasons, but I'm going to address three common ones here, and they happen to be applicable to the project I assign. The first one is the data has unneeded variables or information. Unless you're collecting your own data, you will have extra stuff in there that you don't want. Two, the data itself is not in a usable form. It's text when you need numbers, it's numbers when you need text, it's something of that nature. And of course, finally, the data just isn't even in Excel. It's in some web table or something like that. And how do you even get it into Excel? All right, so I am going to address these three using Excel, as this is what my students use, and many of you, I'm assuming, are using it in the workplace. But the basic ideas will hold no matter what analysis tool that you are using, whether it be SAS or R or SPSS. A lot of times we clean our data maybe in Excel, and unless we're working with really large data sets, and then import it, right? Those are all possibilities. Okay, so first, the data has unneeded variables or information. Often, if someone else collected the data, you have data in your data set that you just don't need. And you might have trouble doing the analysis of it, or just keeping track of what's going on. So we're actually going to start this by looking at the COVID-19 data from the COVID tracking project. It's a great website. I totally recommend it. And in this video, I'm just going to look at how testing and positives are related, and then see how hospitalizations have changed over time. But the current data set actually has several testing and hospitalization headers. So we need to find the correct ones and delete the ones that we don't need. Then we can do our analysis. Okay, so over to Excel, and I'm going to scroll this up before we go over. All right, now let me just show you. I got this from the COVID tracking project API. I went to historical US data and got the CBS file, and so I'm just opening this right now. So what you can see is there's a date column. These are the number of states and protectorates, commonwealths, whatever, that have showed a positive. Here is the total number of positives, the total number of negatives, the total number of tests that are pending. Here's the hospitalized, but this is currently hospitalized. This is the cumulative number of people that have been hospitalized. These are intubators, ICU. These are in ICU numbers on a ventilator. This is the number of people that are recovered. This is some hashtag that they needed for data. Here's another date checked. All right, so we have like the date and then the date checked, right? So this actually has a time in it. Then you have the total number of deaths, hospitalized again, the total number of people, the total number of people that are testing positive, positive negatives, BIPs. I don't even know what that is. We're going over here. And now we've got death increase. So this is strictly the number of increases in deaths. Hospitalized, negatives, positives. So these are all increases. Hospitalized increase, negative increase, positive increase, total test results increase. So basically, these are the columns that I want over here. So what I'm going to do is I'm going to just click on T, column T, that I don't need, that starts the FIPS. And I'm going to start scrolling left, highlighting all of these columns over here until I get to date. And I want to leave date unhighlighted. Now, this would be for any amount of data that you don't need, that you want to get rid of. Once you're here, again, in this header area where the B column is highlighted, you're going to right click and you're just going to delete it. Now I've gotten rid of all of that extra data that I don't really need. Now, I was actually concerned about hospitalizations, positive increases, and total test results increase. And so what I'm going to do is I'm actually going to click on B and get rid of deaths. And then I'm also going to click on negatives increase and click delete and get rid of that. So these are the only 4 things that I care about: the positive increase and the total. Now, with it looking like this, here's another thing. All right, so bonus tip. You've got these zeros in here. We don't have any data for today. Today is currently the 16th. It's the data for today. It's zeros. This doesn't do me any good. So what I'm going to have to do to clean this data up is actually delete those zeros out because they're not true. Those are not true zeros. And then I'm going to scroll down through my data and look for any other anomalies like that. So now once I get down here, I can see I've got all these zeros. These are not really zeros. This is a time period when we were not collecting data. So I want to get rid of all these zeros or I'm going to confuse Excel. Now look what happens as we get further down. I don't know why, but I've got a bunch of zeros down here as well. So it looks like February 27th, from that point forward, we don't have any good CDC data. It looks like there's some ones in here. Those may or may not on the February the 7th. Those may or may not be true. So what I'm going to do is I'm going to go ahead and keep scrolling down until I get to the bottom. I'm going to delete that. So actually, I don't need these dates either. So I'm going to delete that. This is what we mean by cleaning the data. I had to get rid of the zeros. I had to get rid of date ranges that don't apply, that don't make sense. I had to get rid of data that doesn't make any sense. Doesn't make any sense to the analysis, and it doesn't make any sense in terms of the data values that are there. That's why we deleted those zeros. Okay, so now we've got some really nice data where I've had non-zero numbers. Once I have it like this is really easy. I can actually grab these 2 data values right here, scroll down and grab all of them and do some analysis. Like, for instance, these are 2 quantitative variables. I can absolutely put in a scatter plot and go ahead and click on OK. And you can see that the total increases versus testing, this was a really, really nice linear equation. Really, really nicely linear until we got to right about here. And now it's starting to fall apart. Now it's less linear. There's less of a correlation. And so what does this mean? Well, I mean, I could get into it, but it doesn't involve cleaning the data. This is the analysis that we're looking at, okay? And that's a different topic for a different day. Now, that's how we clean that, okay? So, going back. What about if the data itself is not in a usable form? Again, we're looking at COVID-19 data from the COVID tracking project, and it has dates entered in this year, month, day form. For example, today that I'm videoing this, or yesterday, I guess, on May 15th, 2020 is going to look like this, right? Like this date time. Well, this actually looks like a number in Excel, okay? And so this creates many issues with being able to graph this data. As you're going to see when we switch over to Excel, I need to reformat the dates into something that works better. So I choose days since because it makes the analysis much easier. Additionally, if we were looking at state data, you could actually use the days since shelter at home to make a more appropriate comparison of like apples to apples. If you wanted to compare like the changes in cases in Florida, New York, and California, and they had 3 different lockdown days, you would start each lockdown day at 0, right? And then you could look at what was it like 10 days after the lockdown for each of the states. What was it like 30 days after the lockdown with each of the different states? We could currently be doing that with the unlocking, right? Who unlocked first and what does their tracking look like? But if you go over to our daily data over here and we go ahead and scroll up, watch what happens when I tried to grab the date and the hospitalization, and I'm scrolling down here, all right, and now I insert my recommended chart. And so I've got this scatter plot thing right here, right? So I'm going to scroll up and pull this up with me, okay, so that you can see this. Well, what's going on here? Well, what happened is I'm going from 2020 04 to 30, and then I'm jumping to 5 and 1, right? And so this is the end of March, this is April, this is the beginning of May. And so when I jump from the 30th to the 1st, I'm actually changing from 330 to 401. And so it's got this big long line that it's drawing here in between the months. Well, this is totally screwing up all of our data in here. Like these big gaps don't actually exist in our data. So how do I clean that up? Well, the issue here is, and I'm going to delete this so that we're not confused, right? The issue is these dates, right? So I'm going from 331 to 401, and it's thinking that there's a 70 day gap in here the way it's reading these numbers. So what I'm going to do is I'm going to go down right below this last date that we have, and I'm going to type in 0. Okay? Now, we're going to pretend like March 20th was day 0 for the purposes of this analysis. And then we're going to go equals this bottom number plus 1. And you'll see there's a 1 there. And as I drag this up, you'll see that the numbers keep increasing as we go up. So basically what I'm going to do is I'm going to drag this all the way up to the top. There you go. So we got 56 worth of days since. Right, here's my hospitalized increase, so we can look at the total number of hospitalizations increase there. And so now that I have this day since, now let's look at the graph, right? Let's grab this. Let's drop down. I'm going to leave out the 0 right here and go ahead and insert the recommended chart. This looks a lot better. This looks a lot better. Okay, so now we can go ahead and click on OK. Here's our hospitalized increase, and we can see that it's actually relatively flat. We've got a couple of spikes here. Everything else is relatively flat, and I could start doing some analysis. But what I've gotten rid of is all of those big gaps. I have cleaned this data up by doing something over here that helps out. Now, I think I've probably screwed this other chart. Oh, no, I haven't. This chart still looks good. Excellent. Great. So those two things. So that's another way of cleaning the data, is actually changing one of the variables from the values that it has to a value that's actually usable in the analysis. Okay, so now we've actually been using data in Excel, but what if the data is not in Excel, right? What if it's just a table in a web page? Well, the easiest way to handle getting data sets into Excel is through copy and paste, okay? You basically just copy from the table you want and paste it into Excel. So let's go ahead and go over there now. Okay, so I actually have the CDC data on autism is right here. Okay, so I've got basically this table, okay? Identify prevalence of autism spectrum disorder from it looks like 2000 to 2016 combined from all sites. And so I've got some headers here that tell me some things, and I've got these years. So what I do is I go ahead and I'm just going to select, right? I'm literally like inside here, I click, I'm holding down, I'm dragging through the table and highlighting everything here, okay? Now, once I have that done, I can right click and copy this particular table, which is really nice. And now what I'm going to go ahead and do is I'm going to go ahead and paste it into this new chart. Now, there's a couple of ways of doing this. A lot of times what I like to do is right click, and I'm going to hover over. This keeps the source formatting. This just matches the destination. Sometimes you'll have some special options over in here. This looks pretty good. So I like this one. So I'm going to leave it like this, and I'm going to click on it. Okay, so here I have the surveillance here. Here I have the birth year. Here I have the number of reporting sites. Here I actually have the combined prevalence per thousand. So this is like a per capita number. Okay, and this is about how many children. Okay, so this is like the percentage. Oops, I'm going to click cancel. This is the percentage. Now, there's a couple of ways of cleaning this data. Like you'll notice this is some sort of confidence interval down here. And if I don't need that confidence interval, I can click on this row, click on row 4, right click and delete. I can just get rid of those. Right click on 5, delete. Right click on 6, delete. Right click on 7, delete. Okay, so I'm just cleaning this up to get rid of all of those confidence intervals, because if I try to analyze this data with it here, let me go ahead and undo. Right, let's say you wanted to look at like birth year and the combined rate, right? If I select birth year and I select the combined rate using control click, right? And now I try to insert my recommended chart, it's like, whoa, what have you done? I'm so confused. You can't do it that way, right? So I get rid of each of these. I'm going to get rid of this one as well. There might be a more efficient way to do this, but this data is so small that I'm not really worried about it. Now when I select birth year and I select combined incidence, right? And I click on recommended charts. I've got this nice line here. I'm going to do this one. And so you can see that it's going up. I get a value, okay? Again, with this data, right, you could actually convert each one of these. You could actually go 1 in 150 isn't usable, but you could go equals 1 divided by 150 equals 1 divided by 150 equals 1 divided by 125 equals 1 divided by 110 equals 1 divided by 88 equals 1 divided by 68 equals 1 divided by 69 equals 1 divided by 59 equals 1 divided by 54. Okay, so these would be the rough percentages, and of course I could change them into percentages instead of proportions. These are actually proportions. So there it is. Okay, so you can change all of this to however you want so that you can get data that is usable in analysis, right? Oh, crumbs. So one final note, obviously we could talk about merging data from two different data sets, transposing data, or other types of cleaning. But if you know how to get rid of variables you don't need, copy and paste from a table into an Excel spreadsheet, you can do some basic merging, transposing, and some other types of cleaning. But if you want to know specifically about that kind of data, if you've got some data you'd like me to help you clean or something, please leave a comment and I can address it in future videos, as long as it's, publicly available and all that fun stuff. All right. As always, please like, share, and subscribe, especially if this was helpful. I really hope this gets you started on cleaning your own data and being able to do some useful analysis. If you learned something, that really makes me happy.